So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we're going to be talking about an amazing series which represents the natural logarithm of gamma of 1 plus x, or basically you can say natural logarithm of gamma of x, right? So basically we are going to be proving that actually, and I think I should write that down once here. So the thing that we're going to prove in this video is natural logarithm of gamma of 1 plus x is minus Euler mass equivalent times x plus the sum as n goes from 2 to infinity of negative 1 to the n Riemann zeta of n over n and x to the n. Right, so this is the thing that we are going to prove in this video, and it's amazing some sort of, because I have never seen this. And yeah, just take a look at this. Like this equation is relating gamma function, natural logarithm over that, and some Euler mass equivalent constants, and the Riemann zeta function as well. So yeah, it's kind of amazing to just look at that. So yeah, the proof of this is pretty amazing, I would say, because we are going to be beginning our proof from a well-known equation that we have proven earlier, and that is the Weierstrass infinite product for the gamma function. So let's just talk about that. And I'm sure that it's not going to take a lot of time, obviously. So basically we have the Weierstrass product of gamma function, of a reciprocal of gamma function, you can say. And we have proven this. Like, if you are a daily viewer of my channel, so you must have an idea about that as well. Okay, so basically it is 1 over gamma of z equals z times e to the Euler mass equivalent times z, and times the infinite product as k goes from 1 to infinity of, or maybe you can say n goes from 1 to infinity, and it's z over n and e to the negative z over n. So this is the Weierstrass product for the gamma function, and this is pretty amazing. I have proved this, and that the proof of this one is also amazing, so you can consider watching that. And I'm just gonna paste the link of the proof video of this in the description box of this video, don't worry about that. Okay, and we know that z times gamma of z is gamma of 1 plus z, right? Well, you can just think about it, something sort of like that. We know that gamma of 1 plus z is z factorial, right? So this can also be written as z times z minus 1 factorial, and z minus 1 factorial is gamma of z. So hence gamma of 1 plus z is z times gamma of z. I have talked about this a lot of times in my earlier videos, and even I have proved this in my like introductory video of the gamma function. So yeah, so basically if we talk about this equation, so I'm just going to divide both sides with this z. So it's 1 over z times gamma z equals e to the Euler mass equivalent times z, and it's the product, right? And it's 1 plus z over n e to the negative z over n. And then it's just gamma of 1 plus z, right? So we are having 1 over gamma of 1 plus z as e to the Euler mass equivalent times z, and times the product as n goes from 1 to infinity of 1 plus z over n e to the negative z over n. Okay, and now our next step, like we have made gamma of 1 plus z in the denominator over there. So we just have to talk about the natural logarithm of that. So we're just going to take the natural logarithm both sides. So taking natural logarithm both sides actually, so that's going to be natural logarithm of 1 over gamma of 1 plus z equals natural logarithm of this big chunk of things, which is e to the Euler Maslow times z, and times the product of 1 plus z over n e to the negative z over n. Okay. So basically, and let's talk about the natural logarithm a little bit actually, because we are gonna be using that over there. So we know that natural logarithm of 1 over a can also be written as minus of natural logarithm of a, right? Because this can be written as natural logarithm of a to the negative 1, and this negative 1 will become out, that is gonna giving us natural minus of natural logarithm of a, right? And if we talk about the right hand side, so basically your a is this gamma of 1 plus z. So this can be written as negative of natural logarithm of gamma of 1 plus z, right? And if we talk about the right hand side, so we are having natural logarithm of e to the Euler Maslow times the product, and it's 1 plus z over n e to the negative z over n. Okay. So we have to take the natural logarithm of this, right? And we know that natural logarithm of a, look, natural logarithm of a times b. A times b is the argument of natural logarithm. So that can be written as natural logarithm of a plus natural logarithm of b. So basically we are having this as the first one, a you can say, and this is the second one, b. So basically it's natural logarithm of e to the Euler Maslow times z, and plus natural logarithm of this product. Okay, and then since this natural logarithm of e is just 1, and we are having gamma of z, gamma times, Euler Maslow times z over there, and plus if we talk about this one, so I've talked about this as well, but let's just talk about this in this video as well. Okay, so basically it's an infinite product, right, of this argument. So we can consider like natural logarithm of the first term when n is equal to 1, and then the second term is being multiplied to the first term, and then it's just keep going up to infinity, right? So we can write that as an infinite sum with natural logarithm of this argument, right? Because we just used that thing only over here. Basically I'm saying that natural logarithm of infinite product of this argument is the sum of natural logarithm of this argument. That's it. That's what I'm trying to say. Because when we sum these natural logarithm, when you plug n equals 1, n equals 2, and successive terms, so basically if we talk about natural logarithm of a plus natural logarithm of b plus natural logarithm of c, and this just keep going up to infinity, so that can be written as natural logarithm of a times b times c times, and that's just keep going up to infinity. So yeah, basically that's what I'm trying to say. So now we can represent this product and with this argument as something sort of that. So it's the sum as n goes from 1 to infinity of natural logarithm of this argument. So it's 1 plus z over n and times e to the negative z over n. I hope you guys are clear with that, and please don't get confused with that. It's pretty you just have to be focused to understand that. It's pretty easy to understand, right? Okay. And then if you talk about the argument of this thing, actually, well, we were having minus natural logarithm of gamma of 1 plus z on the left hand side, if you might remember from there. So it's negative natural logarithm of gamma of 1 plus z equals, and we're having Euler Maslow times z plus this sum. Well, look, we're having inside the argument of natural logarithm, we're having two functions being multiplied to each other. The first one is 1 plus z over n, and the second one is e to the negative z over n. So again, using this thing that natural logarithm of a times b is natural logarithm of a plus natural logarithm of b. So using the formula, we can say this is natural logarithm of 1 plus z over n and plus natural logarithm of e to the negative z over n. I hope you guys can see all the stuffs, and let me just check this once. Yeah, everything is fine. So we are having negative natural logarithm of 1 plus, gamma of 1 plus z equals Fourier masculine times z and plus the infinite sum, and it's natural logarithm of 1 plus 1 over, z over n, and this can be written as negative z over n because natural logarithm of e is 1. Okay, so far it's perfect, fine. And now let's just introduce something over here. Taylor series expansion for natural logarithm of 1 minus c. Wait. It's 1 plus z actually. 1 plus, let's say, x. So basically it's natural logarithm of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, and plus that just keeps going up to infinity. Right? So basically why I did introduce that, because we can just plug this z over n on the place of x over here, and then we'll just take a look at what we are having so far. So let's just talk about that. So yeah, it's pretty amazing, and you know what? Like using this thing, we are gonna be just producing the Riemann zeta function. You will see that in a while. So that's amazing. So if I'm plugging x equals z over n, so natural logarithm of 1 plus z over n is z over n minus z squared over 2n squared, right? And plus z cubed over 3n cubed, and minus this is keep going up to infinity. And now just subtracting both sides with z over n. So basically we would be getting rid of this z over n on the right hand side, and we would be having natural logarithm of 1 plus z over n minus z over n as minus 2 z squared over, minus z squared over 2n squared plus 3, I'm so sorry, z cubed over 3n cubed, and minus z to the 4th over 4n to the 4th, and plus this keeps going up to infinity. Okay? And yeah, it's pretty fine. So basically, guess what? This is the argument of this infinite sum, and this can be written as an infinite sum as well. So basically, natural logarithm of 1 plus z over n minus z over n can also be written as the sum as k goes from 2 to infinity actually, let's say k, and it's negative 1 to the n minus 1, and it's over n times, it's k, I'm so sorry, it's k minus 1 and k times n to the k, right? And we are having z to the k as well. Okay, so we have just represented this infinite sum as a like series, as a summation over there. So now we are gonna be plugging this back over here actually. So yeah, we're gonna have some double infinite sums over there. So let me just write that down here. So basically, if we're gonna plug this result on the place of this the thing, you can understand that. So basically, we are having natural logarithm of gamma of 1 plus z as we are having Euler masculine times z plus this sum as n goes from 1 to infinity, and the another sum actually this one k goes from 2 to infinity, right? And it's negative 1 to the k minus 1 over it's k times n to the k, and it's z to the k. Yup. Okay. And guess what? We are very close to just to take a look at the Riemann zetas. So So we are having negative natural logarithm of gamma of 1 plus z equals Euler masculinity times z and plus this sum as k goes from 2 to infinity here, and it's negative 1 to the k minus 1 over k times z to the k and times the another sum which we are having from n equals 1 to infinity of 1 over n to the k. And guess what, guys? We know that this is the Riemann zeta of k. Here it is, guys, and this is amazing. So now finally we are here, not finally actually, it's the second last step, minus natural logarithm of gamma of 1 plus z equals Euler masculine times z plus the sum as k goes from 2 to infinity of negative 1 to the k minus 1 times Riemann zeta of k over k and it's z to the k. And now just multiplying both sides with negative sign, so finally we are having natural logarithm of gamma of 1 plus z with negative Euler masculine times z and plus, actually the negative that should be here, I'm just going to multiply that back here actually. So that's going to be giving us negative 1 to the k, right? So it's negative 1 to the k Riemann zeta of k over k and it's c to the k. And here is your final result. So yeah, that was amazing and it wasn't easy at all. We did a lot of things over there, and that's when we just reached up to this amazing result. So yeah, guys, again guys, if you got to learn something out of it, please make sure to subscribe and share. And if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply your questions. Yeah, obviously I'm there. I'm just waiting for your questions. Okay, goodbye guys, take care, love you, and just enjoy your life as much as you can, and enjoy your mathematics as well.